All right, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is another video in the series of, well, Kuta worksheets. That's the title of this thing. There's these kinds of worksheets that are easy to look up, that teachers look up all the time, and that was the inspiration for this, is that teachers use it all the time, and therefore people get assigned these things as homework or classwork or both a lot. And so the answers and the solutions to these could be pretty helpful if you're kind of stumped on one. So that's what this is all about. Let's go ahead and dive into this particular one here. We want to solve proportions. So there are a lot of ways to solve proportions. I'm actually going to do a little bit of a few different methods, and then I'll just kind of zero in on the method that I prefer. And actually, I don't use one method all the time. There's a couple different ones that I like to use. So it just depends on the problem. Let's go ahead and jump into number one, and let's use one of my favorite methods. Okay. Now, if the variable is at the top, right, so the numerator, if the variable is at the top, then you don't have to do any of the cross multiply stuff that you might have heard of or anything like that. You can actually just multiply both sides by the denominator that's underneath the letter you're trying to solve for. That cancels. And then here's your answer. So 10 times 10 is 100 over 8. Now, that's not fully simplified, but I mean, that's it, other than simplifying the fraction. So if the numerator is on the top, you just have to multiply by the denominator, and then you're done, actually. So let's go ahead and simplify this. It looks like they both go into 4. Now, if you weren't sure if they both went into 4, you know they're even, because they both end in 0, 2, 4, 6, or 8. All even numbers end in one of those digits. So we know at least that they divide by 2, so you could divide by 2 and then, do it again. But these guys both divide by 4. 100 does not divide by 8, but it does divide by 4 evenly. So 25 and 2, and that's as far as we can go there. All right, so 25 halves, that's it. Same thing for number 2. We could just multiply both sides by 3. Now, I did say I was going to do a couple different methods. So let's talk about that cross multiply thing I mentioned earlier. So cross multiply, you just make a cross. So when I make a little X here, I'm kind of like Xing out the equals. All right, and I'm assuming you haven't heard of this method yet. So if you already know how to do cross multiply, then you can buffer ahead a little bit if you don't want to listen to this. But assuming you don't know what cross multiplying is, that's what this is. You basically make an X where the equal sign is. And what that means is I'm going to multiply the top left number, in this case 7, by the bottom right number, in this case 3. All right, so 7 times 3, 21. Okay, equals. Then we do the bottom left number, 5, times the top right number, x. All right, so it's a number that we don't know yet. X is a number. It's a variable. It's a number. It's a lot of things. And that's how you set up cross multiplying. Now, cross multiplying works really well when the denominator has a variable in it. X wasn't in the denominator. It wasn't at the bottom. It was at the top, just like number 1. But like I said, I wanted to show you some different methods. So this is classic cross multiplying. This is probably the most commonly taught method. Now, of course, we're not done, because this is 5 times x. In order to solve, I do the opposite. So I'm going to divide both sides by 5. 21 doesn't go into 5 at all. 5 is a prime number, so we're done. 21 fifths. That's it. Cool. And I like to change colors every 2 problems, just because I don't know, rainbows. Number 3. So notice the variable's at the top. If it's at the top, we can do method number 1. If it's not at the top, then method number 1 doesn't work. All right. Another method. All right, so this is the third method. And I usually don't use any other method than these 3. So this is the third method. It's a little bit more complicated, but bear with me here. I'm going to go like this. So you start with the number that's above or below the variable, right? So start with the number above or below the variable. Okay, you multiply across. Multiply across. So I'm going to do 10 times 9. Okay, so 90. And then step 3, you divide by the other number. By the other number. Okay, so we go whoop, like this, and we divide. So 90 over 6. And that should go in evenly. That's going to go in 15 times. So x is 15. There we go. So this method works kind of cool. It's a little bit more tricky because you have to remember the steps to it. You have to start with the number that's above or below the variable, multiply across, meaning like diagonally, right? So when I say across, I mean diagonally, like checkers. And then you divide by the other number. Okay, so you have to remember to do that. So it takes a little bit of practice to get used to it if you haven't done this yet, but this method works really well too. Let's try to use the same method on number 4. Let's see what happens. So according to this method, we start with the number above or below, so that would be this 7. There's step 1. Multiply across. Okay, so times it by 7, we get 49. Divide by the other number, 8. Let's see if this works. So this actually isn't going to simplify. 49/8 is, well, the answer. And then we would have to plug it back in to see if it really works. What if this method doesn't work on the variable if it's down in the denominator, like method number 1? Let's see. And this is a good chance to see if we can check our work, and show you how to check your work. So when you plug it back in, it's going to be a little bit annoying here because we have a fraction. Would have been easier to check it on number 3, I think, but let's just go for it here. So this would be 7 over 49 over 8 equals 8/7. Would that work? Well, if you're allowed to use a calculator, then it's a lot easier. If you're allowed to use a calculator, you would basically just do you would do 7 divided by parentheses 49 divided by 8 close parentheses. So I get 1.14 blah 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 blah. And then we divide 8 by 7. Oh, look at that. We get the same thing. Huh. So it might not seem like this method would work because the variable is at the denominator, but it does. So this method works all the time as well. Okay, that's why I like this method. It's like a one-shot, one-kill method. You just do a set of things here, and it just gives you the answer. Right? It's like a little formula, and then you spit out the answer. I still prefer this method if the numerator is in the denominator, or sorry, the numerator at the top. But I think this is probably my second favorite. Classic cross multiplying. It's just it's the most popular one, so I figured I'd talk about that one too. But these are the 3 methods. Number 1, first method. Number 2, second method. Number 3 and number 4, the third method, but with the variable in 2 different places. Okay. So these are the 3 methods. I'm not saying that it's not more than 3 methods. If you know of another method besides these 3 that I've talked about so far, I would love it if you would throw me a comment and let me know what other methods you know of, especially if you really like that method. Because I've heard of some other ones, but I haven't heard of any good ones, other methods to do this, to solve these proportions like this. So if you have, let me know in the comments. But we're going to go ahead and move on here. Oh, actually, you know what? I take that back. There is one other thing. There is one other method that we can talk about. So if this is a little tricky as well, but it's kind of a cool little trick method. If you can get from one side to the other, either going from left to right or right to left, if you can take the, let's say, top left times something, a nice number, to equal the top right, right? So top left to top right to top left, or bottom left to bottom right to bottom left. All right, if you didn't get all that, you can rewind a little bit. But basically going not diagonally, just straight across, horizontally, and multiplied by something nice, then that's actually another method as well. So there's actually a fourth one. So I don't know if I mentioned that I was only going to do 3, but here's a fourth one that I just forgot I knew of. And this is sometimes called the scale factor method. So 4 times 2 is 8. then if I can times that by 2 going from left to right, that means that I can do that down here as well. Now this only works for timesing. So 4 plus 4 is also 8, but I wouldn't say 3 plus 4 is the answer. Right? So plus and minus out of the question. Only timesing. You can also do dividing, since dividing is basically just multiplying by the reciprocal. So multiplying or dividing works. Adding and subtracting, not so much. So I can times by 2 to get from 4 to 8, which means 3 times 2 must be the answer. So x is 6. Another method. All right, cool. So that method is not going to work on number 6, unfortunately, because we have b plus 5. So we don't know what b is, which means we don't know what b plus 5 is. Okay, b plus 5 represents something we don't know. It just represents something we don't know and 5 added to that. But we also don't know what b plus 5 is. So we can't do anything with that as far as like simplifying it or anything like that. Now, we can simplify over here. 10/5. Here's another thing we can do. 10/5 is just 2. This is equal to 2. All right, so there's a lot of different methods. I am going to stick to one method eventually, I promised. But I wanted to show you as many methods as I think are really good methods. That way you can try a couple of these different methods out. Maybe you've been learning using one method, like let's say cross multiplying, and you're not a huge fan. I'm not a huge fan of cross multiplying, and that's the most popularly taught one. So I like to give you a bunch of different methods so that you can pick for yourself and see which one you like the best. But anyways, this is equal to 2 here, or 2 over 1. We can say 2 over 1. And I'm not sure what the best method is here. We can't do the method that we just did on number 5. But we also can't do the method that we did on number 1, which is probably my favorite because it's, I think, the easiest. But we can do that other method that we did on number 3 and number 4. So let's go ahead and do that. Start with the number that's above or below the variable. Multiply by the number across. Then divide the other number. And that equals, well, the answer. But the answer this time is the b plus 5. So we have to include that b plus 5 there. So this method doesn't seem to be as nice because I'm going to have to subtract 5 on both sides. And then I have fractions with unlike denominators. 5 is 5 over 1, which is 10 over 2. Right? 10 divided by 2 is 5. Therefore, 10 over 2 is 5, but I have to write it like this, so that way I can subtract the fractions with unlike denominators. Yuck. But it is what it is. Negative 3/2 is the answer. Okay. If you have a calculator, obviously you have a calculator. Everybody has a phone with a calculator. But if you are allowed to use a calculator is what I mean, then, you can. And then you can just get a decimal. Be careful if you get a repeating decimal, because you don't want to try to round, because likely your teacher will want an exact answer. So as long as you get what's called a terminating decimal, meaning like it ends at some point, it doesn't like keep going and going and going, and you have to cut it off somewhere. So if it doesn't go all the way out to the end of the screen on your calculator, then you can use that decimal instead if you want, and then like change it back into a fraction later maybe, if your teacher prefers the fraction as the answer. But this is the way to do it by hand. All right, cool. Let's go ahead and move on. I know this is taking a hot second here, but as we move along here, I'll start to just kind of, hone in on one method and just stick with that. Speaking of, let's go ahead and do this one. So let's do the method that I like to do the most, which is probably this one. 6 times 7 is 42. The answer to life, the universe, and everything. That was a Hitchhiker's Guide to the Galaxy, by the way. That was a Hitchhiker's Guide to the Galaxy reference. So I think I put divided by 2. I don't know why I did that. 6 times 7 is 42. And then we want to divide by 9. Okay, and that equals b minus 1. We want to add 1 to both sides. Now 42/9 is not fully simplified. It divides by 3 14 times. So this is 14/3. We want to add 1 to both sides, so plus 3/3. And then this would be 17/3. Oof. Tricky fractions. I would have shown more steps on that one, but there's really not that much space on this worksheet to do so. So Oh, hey, this one we can do that little trick. So this is actually 8 halves, by the way, is just 4, or 4 over 1. So if these are both 4s for numerators, that means m minus 8 is equal to 1. Right, little trick there. If the numerators are the same, or if the denominators are the same, then the other thing has to be the same too, because they have to be the same fraction. Then we would add 8 to both sides, and we get 9. Ah, that was nice. All right, on to the next. 6 to 9, and there's not really a nice number, kind of-ish, but not really. So we're just going to go ahead and, let's go ahead and do cross multiplying on this one. Why not? So cross multiply here. This would be 6 parentheses 7n plus 9 equals 45. So then we want to distribute, so that's 42n plus 54 equals 45. Subtract 54 on both sides. So that's actually going to be negative 9. And then divide by 42. And then this is going to simplify to negative 3/14. All right, cool. Kind of the same thing here. So we can cross multiply again. What else can we do? Oh, it's in the numerator. Remember, when it's in the numerator, you can just multiply both sides by the denominator. So we can do that. This is the first method I ever did on this worksheet here. Oh, wait. Didn't mean to do that. Can I? I can't control Z? Darn. All right, well, I tried. Just pretend like that slash on the 9 is not there. This would be 6 times 4 is 24. Ninths. Those 6's would slash out, and we would get r minus 3. So we would want to add 3 to both sides. Now, 24 ninths I can simplify a little bit because they both go into 3. If I divide by 3, that would be 8. If I divide 9 by 3, I get 3. We want to add 3 to both sides. 3, we want to add 3, which is adding 3 over 1, which is adding 9/3. All right, so we want to add 9/3. All right, so that was that over there. Wanted to kind of separate that from here. So we want to add 9/3 to both sides. 8 plus 9 is 17 thirds. And we get that for the answer. So we got the same answer for number 7 as we did for number 10. Huh, interesting. All right, on to the next. Let's see. Ooh, there's a variable on the top and on the bottom here. Let's just do some classic cross multiplying again. 9b. If there is a variable in 2 different places, then you cannot do the whole start with the thing above or below the variable because there's more than one variable. So you can't do that method. That method that I did, that method that I did on number 3, you won't be able to do that method because there's a variable in more than one place. So you're kind of limited here. That's why I think cross multiplying is the most popular, is because it works on everything. So anyways, 9b equals 7b minus 10. So we want to distribute here. 9b equals 7b minus 70. Then we want to subtract 7b from both sides, and we get 2b. 2b or not 2b. And then divide both sides by 2. Negative 70 over 2 divides and gives us negative 35 for the finale respuesta. Let's see. Again, variables in 2 different places, so we're kind of limited. Cross multiplying works. That whole trick where if you can multiply or divide by a number to get across, straight across, horizontally, that trick still works as well. But other than that little trick, cross multiplying is really your only option once you have variables in more than one place. Those other methods I showed you earlier don't work on more complicated problems like these. So 9k equals 6, k minus 7. Distribute the 6. 9k equals 6k minus 42. So then we subtract 6k on both sides. We get 3k. And that's going to divide evenly. That's going to be negative 14. We're getting a lot of negative 14s. So it's kind of weird. I feel like they're doing this on purpose. Whoever built this worksheet was like, let's make negative 14 a thing. Make them think they're doing something wrong. All right, let's cross multiply here. So this is going to be 4n. And like I was saying before, you can really only cross multiply unless you can multiply by something to get straight across horizontally, which we can't for number 13. So we're kind of limited to cross multiplying. It looks like pretty much from here on out. Distribute 4n, 7n plus 14. Subtract 7n on both sides. You get negative 3n equals 14. This is not going to divide evenly. Get this 14 thing coming up all the time. This is kind of weird. All right, 3n, cross multiply, 3n, and 2 times n minus 3. Notice I have to distribute. Anytime you have a binomial or greater, you have to distribute. Sometimes you have to FOIL. I think we're going to have some foiling later on here. 3n equals 2n minus 6. Subtract 2n on both sides, and I get n equals negative 6. All right, and that is why I like to keep my variable positive, because sometimes that happens. All right, switching colors again. So cross multiply, 10, x minus 3, 9x, distribute, 10x minus 30 equals 9x. Let's do this. So we subtract 9x on both sides, add 30 on both sides. That goes away, that goes away. 10x minus 9x is x. We add 30, x is 30. You don't have to do it that way. You could have also subtracted 10x on both sides and then divided both sides by negative 1. Either way, it would have taken 2 more steps to get the answer that way. So let's see. So we go on to the next one here. 5, r plus 5. Sorry, that 5 looks weird. Equals 8, r minus 9. 5r plus 25 equals 8r minus 72. We're going to subtract 5r from both sides, so 3r. Then add 72 to both sides, we get 97. Yeah, 97. Which doesn't divide by 3. Ugh. Okay, so minus 5, we get 3r. Add 72. Yeah, that's weird. I mean, we've been getting fractional answers, but this is a really ugly fraction. Oh well, whatever. Let's see. We're on to red now. And I think we're almost done. Yeah, because here's the answers. They have the answers as decimals. Oh, man, those peasants. Writing the answers as decimals. All right, so 3. No, I said 3 and I wrote 8. Goodness gracious. P minus 7. Oh, by the way, shameless plug for a free guide that I have for you. It's called The 5 Math Mistakes Everyone Makes and How to Avoid Them. It's pretty cool. You should check it out. And it's exactly what it sounds like. I mean, I didn't try to be all fancy with it. I was like, I'm going to title this exactly what you get out of it. So it's called The 5 Math Mistakes Everyone Makes and How to Avoid Them. I'm revamping it, and I'm going to kind of turn it into more of a thing where it's like talking about what you should do to get the right answer instead of what you should not do to get the wrong answer. So it's a little more positive. So when that comes out, I will definitely be talking about that as well. But you'll always have access to that old one, and it's pretty awesome. It's just what to avoid instead of what to do to get the right answer. Anyways, subtract 8 on both sides. I got P. I am terrible at double tasking. We subtract 90 on both sides. 1, 4, 6. Ooh, big answer. So, yeah, awesome free guide. It's on my website, myersmathematics.com, just like the name of my channel with a .com in it. I also have an SAT mini course. I have a mini course right now in another place that I give my SAT students for free, but I'm making another one of those as well that's going to be super, super awesome, more awesomer, and I'll be releasing that one soon as well. I'm working on quite a bit of things right now, actually. SAT prep stuff. I do a lot of SAT prep, but I also really like algebra, geometry, all the other stuff actually as well. Make sure I did everything right here because I'm terrible at double tasking. Subtract 2 in on both sides. Subtract 32. Yeah, it looks good. So we just need to simplify this now. They're both going to go into 2. So negative 20 over 3. Negative 20 over 3, positive 20 over 3 is a very good approximation for pi, actually. Fun fact. Oh, was it? Or was it something else? Maybe it was 20 over 7? No, it was 20 over... Was it 20 over 6? You know what? Actually, I don't remember now that I think about it. But there was an approximation. Oh, no, it was 22 over 3. 22 thirds. No, but that wasn't right either. 22 sevenths? Yeah, it was 22/7. That's what it was. I don't know how I got 23rds. Maybe because the 3, because pi is about 3. Anyways, let's go ahead and round this off here. N plus 8, 7, n minus 5, 2n plus 16 equals 7n minus 35. Subtract 2n on both sides, so we get 5n. Add 35 to both sides, and we get, that'd be 40, 51. Man, they really like to give us fractional answers here. That does not simplify again. Lots of fractional answers on this one. And we're almost done here. So if you've enjoyed this video, as any good YouTuber should, they invite you to like it, subscribe, turn on the bell for notifications. I come out with videos every Tuesday at 4 p.m. Eastern Standard Time. So stay tuned for more awesome resources. I'm doing this series right now, but every now and then I'll take a break and do a video on something else that I like to do. So I just did a video on what you should do on your first day of school. So I'll probably leave that in the description. It'll probably be on the bottom right now as we speak, as we're finishing this up here. We're going to add 63 to both sides, so I'm basically subtracting 63 and 12, which would be 51. And we have 51/7. That, actually, does that simplify? No, it doesn't, because 49 would go in, but 51 wouldn't. Okay. Let's check. 51/7. I think they rounded everything to 2 decimal places. Did it say to round to 2 decimal places? It just says solve. Yeah, but they rounded all of their stuff to 2 decimal places. That's so weird. They normally don't do that. Okay. Well, anyways, if I got any of these wrong, let me know in the comments. I didn't check all of them. I only really checked number 4. You should check them if you're doing a test or a quiz. If you're just doing a worksheet, you can, check the answers. So you don't need to, worry about checking your work as much because you have the answers. But on a test or quiz, you won't until it gets graded and handed back to you. So if I got any of these wrong, let me know. But there's the answers. And of course, you can look this up yourself and get the answers that way. This is called solving proportions. You can also type in the word Kuta, K-U-T-A, and it'll come up that way as well. So that's it. Have an awesome day, and I will see you again in another episode really soon.